Hi. In the next video, I want to take you guys through the little bit more of the circuit diagrams, as well as how I'm planning to hack into the display unit of the coffee machine to allow me to display whatever is being shown on the coffee machine's display on the 10 character by 1 line dot matrix display. How I want to hack that out and send that via the Arduino to the server so that I can display that information on the web app. So let's take a look at the schematics, and I'll take you through some of the datasheet stuff. And yeah, let's have a look. Hopefully it all works.
So this is the circuit diagram I went through in my previous video. And one of the inputs is over here. So this is coming from the 10 by 1 character dot matrix display, and the additional buttons here are going to the six buttons on the display unit. In the teardown video, I went through and we had a look, and we noticed that there was 5 lines going in: VCC, ground, data, clock, and a deload. We also noticed from that video that we had a 74595 inside the display unit. So the idea is to read the data from this display and just send it via the Arduino off to the PC via the USB port, so that you can display the same information on the connected web app. So I was thinking of how would that be done. I would like to obviously hack into the signal path, and that's the idea that I'm doing here. I'm just taking these, passing them straight through some optical transistors. Theoretically, the minor voltage drop that the diode or LEDs in there would require should not affect it. Well, that's a theory, of course. And I'll send those off to 3 lines, 3 input pins on the Arduino. So these guys come to this little 10-pin connector on the device, and the best circuit I can think of what that looks like inside would be a set of 7 74595s connected to the 10 character displays with 5 by 5 LEDs in each character. So in theory, we should have the latch line turning on, whole lot of data getting clocked into via the serial pin 14 on the 74595 in conjunction with the clock line, and these cascading through to each of the subsequent 74595s. That one sends to that one, and off and off and off. So at the end of the day, 7595s will give you 56 bits that you can convert serial to parallel. So I'm guessing that somewhere there's 1 bit that is not getting used. If I had to build a circuit, I would leave it to the end, but that could be anywhere. It might be on the first device. In fact, this input, this arrangement could be completely different. They could send it to that character first and pipe off the rows later, so they could do all the columns first and then the rows. So the idea is to strip down the machine again, hook up a oscilloscope to the data line, and have a look at what is getting sent out there. Once I've confirmed that that is roughly what we're looking at here, I will actually connect that to an Arduino and try and read in a couple of data sets. So from there, let's maybe look at some. I've written a bit of pseudocode. Really, I've typed it into Arduino, but I haven't really tested it or uploaded it all. But it does compile. So the idea is that I've got the 3 input pins. I'm using analog pins in this case, mostly because it's the only pins I have available or left in that batch. So latch pin is going to be analog 0, clock pin is coming into analog 7, data pin is coming into analog 6. I've got 3 variables, which I'll get to a bit later. I'll show you what they do. Latch by default set to 0, clock by default set to 0, and a bit counter also just set to 0, and a data string where I'm planning to store the data. In my setup method, I'm setting the 3 pins to input pins, and I'm just starting a default serial loop, or starting the serial command. In the loop section, what I'm doing is I've got, I read the latch pin. So if the latch pin has changed since the last loop, it means that it's either been turned on or off, right? Otherwise, I don't really need to worry about the latch pin. It's either in the on state or the off state. So let's for a moment assume that it changed. If it's 0, okay, so it's turned off. So I need to go through the 74595 data sheet, but so that might change to 1. But the point is, if it's in its on state, if it's in its off state, I will send the data that I've collected to the Arduino, to the PC via the USB, and I'll set my bit counter back to 0. So in theory, this means that it's received 55 data bits, and it's now turned the latch off, which means the data is going to get displayed on the LED matrix, and the coffee machine will go off and do something else. If the latch pin, however, is in its on state, so in other words, when it's receiving data, I again read in the clock pin. If the clock pin has changed, so if this loop happens faster than the frequency of the clock, you'll hit the clock on state multiple times and the off state multiple times. The only time we really worry about it is if it's changed since the last clock. So I read the clock pin. If it's changed, if the clock is high, again, I need to just confirm whether it is reading data in when the clock is in a high state or whether it's in a low state. I need to confirm that in the data sheet. But if it's reading the data in, I can read the data pin, append that to the data string, and increment the bit counter. When I come out of that, I just need to read what the clock was, put that into the variable, and we come around for the second loop. So every time the clock changes, clock changes and it's in its up state, because it should remain the same in the down state. I come in and read the data and clock it out until the latch pin is set off, in which case the data is displayed and I can at the same time send the data to the PC via the serial port. So here we're looking at the 74595 data sheet, and what we can see here is that the latch pin is active low. We can also see that from up here. So the output enabled input active low. So we need to be reading data while the latch pin is low, and we can read the clock pin I've got it while it's on, which means that should be a safe time to read it. So the only change we need to make is to check whether the latch pin is low instead of high. Going back to the Arduino sketch, what we need to do then is, if latch is equal to high, it means the data is being displayed, so we're not receiving any more data. Otherwise, we are busy receiving data, and that's when we need to read it in. So that should be the only change I need to make. So the idea is to follow this video up with a teardown, another quick teardown, and then hooking up an oscilloscope to that pin, having a look at what the data looks like when it comes out there. And I'll also then try and read it into the Arduino, which is currently on a breadboard, to hopefully get the most of the software sorted out by the time I get the boards back from Osh Park. And I'll keep you guys posted. I'm still waiting for the post office on that one, because on the Osh Park site they've stated that it is shipped. So now we're waiting for the South African Postal Services.